Welcome to the Session 6 Classwork solution. If you guys haven't already tried the Classwork, go ahead and do that now and then come back to this video to check your work. Let's get started. Question number 1. A 50-foot ladder rests against a wall so that the top of the ladder is 48 feet from the ground. As you start to climb the ladder, it slips. If the top of the ladder drops 8 feet, how many feet does the bottom of the ladder slide from its original position? Alright, so in order to solve this problem, we're going to use the Pythagorean theorem, which states that the squares of the two legs of a triangle equal the square of the hypotenuse. So we have the x squared plus 48 squared equals 50 squared. Now we simplify that and we get that 48 squared equals 2,304 and 50 squared equals 2,500. Next, we subtract 2,304 from both sides of the equation, and that results in x squared equals 196. The only thing left to do is to take the square root of both sides of the equation to get that x equals 14. We then repeat the exact same process for y, and we get that y is equal to 30. The only thing left to do is subtract x from y to figure out that the total amount that the ladder slipped away from the wall is 16 feet, and that's the answer. Number 2. The following shape is made up of 3 rectangles, each measuring 3 centimeters by 1 centimeter. What is the perimeter of the shape? The thing that you really had to see in order to get the answer to this question is that the blue lengths, the sum of them is equal to the red length, right? Whether or not that top block is there, the total length across the top of the figure is going to be the same. So even though we don't know what the individual lengths of those blue lines are, we do know that they equal the length of the red line. And the red line is just 2 block lengths, and we know that the length of a block is 3 centimeters, and the red line spans 2 blocks, so the red line is 6 centimeters. Because the red and the blue lines add up to be the same thing, we know that those blue lines, the sum of them, is going to be 6 centimeters. Problem 3 asks us to find an unknown value, x. In order to do this problem, the first thing you're going to want to notice is that these two sides are congruent, meaning that this is an isosceles triangle. So the two base angles, meaning the angle that isn't at the intersection of the two sides that are the same, both of those two base angles will always be the same. So that other angle is also 65 degrees, meaning that that third angle in that tiny little triangle is going to be 180 minus 2 times 65, which is going to yield 50 degrees. Now, because there's an intersection of 2 straight lines there, the 2 vertical angles, meaning 2 angles that are directly opposite of each other, are going to be the same. So since one is 50, the other will also be 50. So now we just know that x is going to be equal to 180 minus 50 minus 90 equals 40 degrees. Question 4. The sum of the area of the 6 congruent circles is 150 pi centimeters squared. What is the area of the rectangle? So we know that the sum of the circles is 150 pi centimeters squared. So one circle is going to be that divided by 6. And so when we divide 150 pi by 6, we get that one circle's area is 25 pi. We also know that the area of a circle is equal to pi r squared. So we can set this area equal to pi r squared. We have 25 pi equals pi r squared. Now, we can then go on to solve for r. We divide by pi, we get that 25 equals r squared. And by taking the square root of both sides, we get that r equals 5. So we can also see that the height of the rectangle is 4r and the width is 6r. So the area is going to be equal to 20, which is 4 times the radius, times 30, which is 6 times the radius, which is going to make the total area equal to 600. Question 5 asks for the area of the shaded region. So in order to solve this problem, we're going to start by finding the area of the parallelogram. The parallelogram's area is going to be its base times its height. So that's 80. Now next we're just going to subtract the area of the triangle. Now we have to find the base of the triangle. We know that both of the bases of a parallelogram are the same. So the bottom has to add up to 10, so the base of the triangle is 4. So 1/2 times base times height is going to equal 16. Now all we have to do is subtract the area of the parallelogram. We have to subtract the white triangle's area from it, and we're going to get the area of the shaded region, which is 64.
Question 6. ABCD is a rectangle, D is the center of the circle, and B is on the circle. If AD equals 4 and CD equals 3, then what is the area of the shaded region in between?
So we're going to start out by finding the radius of the circle, which we can use the rectangle to find. So the rectangle's dimensions are 3 by 4, which means the diagonal of the rectangle is 5 by the Pythagorean theorem. So r is going to equal 5. We know that the area of a circle is equal to pi r squared. We only want 1/4 of that, so we're going to divide both of those by 4. Now because r is 5, we know that the area of that quarter of the circle is 25 pi over 4. Now we just have to subtract the area of the rectangle. So the area of the rectangle, as we said, is going to be 3 times 4, which is 12. So then we just have to subtract those two values. So we have 25 pi over 4 minus 12 is our answer.
Question 7 asks us to find another unknown angle value.
So we're going to look at this smaller red triangle in order to solve this. So this angle is going to be 180 minus 35 minus 15, because those are the other two angles in the triangle, and those angles, all three of them, need to add up to 180. Next, this angle is supplementary to the first angle we found, meaning that 180 minus the value of the first angle is going to equal this angle, which is 50. Next, we can find this angle with the same method that we used to find the first angle, 180 minus the other two angles in the triangle, meaning that this angle here is going to be 105. And then x is going to be supplementary to 105, meaning x has a value of 180 minus 105, so x is going to equal 75.
Problem number 8. In the diagram, the small squares are all the same size. What fraction of the large square is shaded?
Alright, so since all of the small squares are the same size, we can just count them up. So the white squares, you can see the ones in the corner are going to be 1/4 of a square, and the ones on the edges are going to be 1/2 of a square. So let's count up all of the white squares. You can see that there's going to be 1, 2, 3, 4 total just full squares. And there's also going to be 1, 2, 3, 4, 5, 6, 7, 8 half squares. So it's going to be 8 times 1/2, which is going to come out to be 4 more squares. And then we also are going to have 1, 2, 3, 4 quarter squares. So 4 times a quarter, which is going to come out to be 1. So 4 plus 4 plus 1 is going to equal 9. Next, we count up the dark squares. We can just see, just looking at the diagram, that all of the dark squares are whole. So it's really easy to just count them up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 dark squares. So since half of them are white and half of them are dark, 1/2 of the total area will be shaded.
For problem number 9, it refers to a figure that obviously isn't present on the classwork. So we're not going to ask you to do that one because there's no way that you could have. So we're going to move on to problem number 10. Question number 10 asks, what is the height of a stop sign whose sides are 1 foot long? And a stop sign is just the shape of a regular octagon.
So I've started off with a little diagram, and if we look at the little triangle in the upper right, we can use the Pythagorean theorem on that. We know the hypotenuse is 1, and we know that x squared plus x squared equals 1 squared, meaning that 2x squared equals 1. Then we divide both sides by 2 to get that x squared equals 1/2. Taking the square root of both sides, we get that x equals 1 over the square root of 2, which can be simplified to the square root of 2 over 2. Returning to the diagram, we're going to see that the height is equal to x plus x at the bottom, plus that middle section, which is equal to the side length, which is equal to 1. So h is going to be equal to 2x plus 1, which is equal to 1 plus the square root of 2, which is our answer.
Problem number 11. The large circle has diameter AC. The two small circles have their centers on AC and just touch at O, the center of the large circle. If each small circle has radius 1, then what is the value of the ratio of the area of the shaded region to the area of one of the small circles? This is a complicated problem. Here's how we're going to approach it. First things first, we're going to find the area of the shaded region, which you'll notice is half of the area of the large region minus the area of one small circle. So we'll find that, and then we'll find an area of one of the small circles, and then we'll find the ratio between the two.
All right, so because the area of the shaded region equals half the area of the large circle minus the area of the small circle, let's start by finding the area of the large circle. So we know that the radius of the small circle is equal to 1. Because of this, the radius of the large circle is going to be equal to 2. So we have pi r squared, so pi times 2 squared is going to be equal to the area of the large circle. Because we only want half that area, though, we are going to divide both sides by 2. So we have the area over 2 of the large circle is going to be equal to 2 squared pi over 2, which is 2 pi. Now, let's find the area of one of these smaller circles. The area of the smaller circle is pi r squared as well, but this time r is 1. So it's going to be pi times 1 squared. So the area of the small circle is going to equal pi. Now recall, we're trying to find the ratio of the shaded region to the area of the small circle. So let's figure out what the area of the shaded region is. Well, it's the top number minus the smaller number. 2 pi minus pi is pi. So we have to find the ratio. Well, we're actually just finding the ratio of pi to pi. The ratio of two of the same numbers is always going to be 1, and so that's the answer.
Problem 12 asks us to find the size of angle QSR. To begin, let's assign the various angles variables. Angle PSQ will be x, and angle PQS will be y. Now, it's time to relate these two values, and we can use the ratio in order to do so. The ratio is 1 to 5. This means that x over y is equal to 1 over 5. If we cross-multiply this equality, we get that 5x is equal to y. Now, let's assign the angle QSR a variable of a. Writing this in, we can see that x and a are complementary angles. Thus, x plus a equals 90 degrees. A will then equal 90 minus x. Let's relate y and x geometrically. We know that x plus y plus 90 degrees is going to equal 180 degrees because there are 180 degrees in a triangle. This means that x plus y is going to equal 90 degrees. Now, we can substitute in y equals 5x to get that 6x is equal to 90 degrees. We divide both sides by 6, and then we get that x is equal to 15 degrees. Now we must plug that into our relationship with a. A equals 90 minus 15, and thus a equals 75. And that is our answer. Question number 13 asks us which one of the sectors represents the mode. The mode is the sector that has the largest number of degrees, therefore the mode is sector A, 94 degrees. Problem number 14 asks us to find an unknown angle value x. Begin by realizing that all of these sides are congruent because it's an equilateral triangle and squares. Next, because it's an equilateral triangle, we know that this angle is 60 degrees, and obviously both of the corners of the squares are 90 degrees. This is an isosceles triangle at the top, so both of the base angles are the same, and we'll give the third angle a value of y. Y plus 90 plus 90 plus 60 is going to equal 360 because you can see in the center there's a single point and it is surrounded by those four angles. And all of the angles surrounding a singular point will add up to 360. We can use this to solve for y. When we do the math out, y ends up equaling 120. Now, we can use this y value in order to find a value of x because we know that the sum of any interior angles of any triangle is going to equal 180, so y plus 2x is equal to 180. Let's substitute y into this equation. So we get 120 plus 2x is going to equal 180. Next, we're going to have to isolate x. So we subtract 120 from both sides. We get that 2x is equal to 60. And next, we have to divide both sides by 2. And we get that x is equal to 30. And that's going to be our answer. Problem number 15 asks us to find the sum of two unknown angle values, x and y. Let's take a look at the diagram. We know that each of the corners is going to be 60, and we know that the corner of the square is going to be 90. So let's give these other two a value of a and b. So we know that x plus a is going to equal 180 minus 60 because the sum of the interior angles is indeed 180 degrees. And we're going to know the exact same thing about y and b. We're going to know that y plus b equals 180 minus 60. So both a plus b and y plus b are going to equal 120. All right, so let's relate a and b. Or actually, let's isolate a and b. So we know that a is going to be equal to 120 minus x. Because 180 minus 60 is 120, and then we subtract x from both sides to get 120 minus x. And we know the same thing about b and y. We know that b is equal to 120 minus y. So now let's relate a and b to each other geometrically. Now we know that along that straight line that a, b, and the square are, we're going to know that a and b and 90 degrees are going to make 180 degrees, which means that a and b have to be complementary. So a and b are 90 degrees. And this means that when we substitute those two things in, 240 minus 90 is going to equal x plus y. Because we substituted 120 minus x for a and 120 minus y for b, and then we rearrange it so that we isolate x plus y. And 240 minus 90 is 150. Problem number 16 asks us to find angle TVU. All three of these shapes are regular polygons, so their interior angles are already determined. For the equilateral triangle, it's going to be 60. For the square, it's obviously going to be 90. And for the hexagon, it's going to be 120. So we can figure out that fourth angle by setting all the sum of the four angles equal to 360. So then we get that that angle is going to be 360 minus the sum of all the other angles at that point, which is 270. So we know that angle TUV is going to be 360 minus 270. This comes out to be 90 degrees. So we know that angle TUV is 90 degrees. But that's not the angle we're looking for, actually. We're looking for a different angle. We're looking for TVU. So we're going to connect T and V. And we're going to realize that since all of these are regular polygons, they all have the same side length, so this is congruent. So the two base angles are actually going to be the same. So we're going to call that X. Now, again, the sum of the interior angles of a triangle is going to be 180. So we know that 2x plus 90 is going to equal 180. And then after that, all we're going to have to do is solve for x. So again, we know 2x plus angle TUV, which was 90, is equal to 180 degrees. And then we just solve for x, and we get that x equals 45. Problem 17. Jack has 5 sticks, measuring 5, 5, 8, 14, and 14 centimeters. Using exactly 3 sticks as the sides of the triangle, how many non-congruent triangles are possible if the sticks are joined only at their endpoints? The first thing we have to realize is that we can't use 5, 8, and 14. We can't use 3 different stick lengths because it violates the triangle inequality, because 5 plus 8 is 13, which is less than 14. So that means that every angle we have has to have either 2 or 3 sides in common. We can't have 3 because we don't have 3 sticks of the same length. So they're all going to be isosceles. So 5, 5, 5, 5, and 8 works, but 5, 5, and 14 violates the triangle inequality. 14, 14. 14, 14, and 5 works, and 14, 14, and 8 works. So that's going to be 3. Problem 18. The length of each side of an isosceles triangle is a prime number. The perimeter of the triangle is greater than 21 units and is not a prime number. What is the lowest possible perimeter of the triangle? So we actually want to pick the smallest prime number possible, which is 2, as our base. So we're going to pick 2 down there, and then the number that we need in order to get up to above 21 is going to be 11. So then 11 plus 11 plus 2 is equal to 24, and that's our answer. Problem 19. The time is 4:40 p.m. What is the degree measure of the smallest angle formed by the minute hand and the hour hand? So there's 360 degrees in a circle, and there's 12 hours. So we get that there's 30 degrees per hour, or per number. So obviously from 0 to 8 is going to be 8 times 30 degrees per number equals 240 degrees from 12 to 8. Now we look at the other one, and that's going to be at 4 2/3, right? Because it's 40 minutes between 4 and 5. So 4 2/3 times 30 degrees is going to be 140 degrees. And the difference between these two numbers is 100, which is the answer. Problem number 20. The long diagonal of a rhombus is 3 times the length of the short diagonal. The perimeter of the rhombus is 40 centimeters. What is its area? So let's take a look at this rhombus. We're going to look at 1/4 of the rhombus. So we know that 9x squared plus x squared equals 100 by the Pythagorean theorem, and x is going to represent half of the length of the diagonal of the smaller diagonal, and obviously the longer diagonal will be 6x. So we get that x is going to be equal to the square root of 10. So when we plug that back into our formula for the area of a rhombus, which is half of the product of the diagonals, we get that the product of the diagonals is going to be 12x squared, and half of that is going to be 60. That's going to be all for today. I hope you found this video helpful. If you did, remember to like it and subscribe to the Agora Math Circle YouTube channel.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!